Hey friends, I'm Scott Hanselman and it's Microsoft Build. We're at an Ask the Experts session. This is a great session where we're going to say, you've got your Windows in my Linux. We're going to talk to a series of experts from Intel and Microsoft on the Windows subsystem for Linux, one of my favorite topics. So I'm really excited about this live session, being able to moderate and ask questions of the smart people who make these things happen and who use them in creative ways. Let's take a look at our panel. Certainly our panel is me. I'm happy to be here, but we also have Dr. Masumi Hazra, Principal Engineer at Intel, and Ben Hillis, Senior Software Engineer Lead on WSL at Microsoft. Glad that you're all here to chat with us and hopefully answer questions of the audience. So the first thing I'm going to do is I'm going to turn to Dr. Hazra, Masumi, and I want to ask you, how does Intel use Linux apps on Windows?
Hi, good to be here. So that's a good question. So as more cloud applications are being developed that are running AI functions and containers, we believe that the client PC can become a premium extension of the cloud services, and we can run these containers in the client. For example, if you have Azure Cognitive Services application running face detection, it will definitely benefit from running in the client because of improved responsiveness and reduced network traffic. And then we want to run sometimes these applications for security and isolation reasons inside the VM. And the Windows subsystem for Linux is providing us with this lightweight Linux VM for Windows, where we can run our Cloud Linux containers on the client so as to become the extension of the cloud services.
Interesting. And you point out in that answer that this is in fact a lightweight virtual machine. I'll turn the question to Ben and say, what if I already have a Linux virtual machine? Maybe I'm already using Hyper-V and I have a square within a square. Why should I care about WSL at all?
Right. I think the benefit of WSL is it gets rid of that square, right? It tightly integrates, whatever you're doing on the Linux side with what you're doing on the Windows side. It really gives you an environment where you can do both and you don't have to context switch between, oh, this is my Windows box, I have to do this, and now I need to switch over to do my Linux workload. It really lets you, use the tools that you're comfortable with, whether it be on Windows and Linux, and use them side by side and just really, additive rather than a choice of Linux or Windows. It's just an ecosystem that supports everything.
That's actually a really great point. I think that people kind of almost have to see it to believe it. This is something that is really integrated, and it's not. I don't think about operating systems anymore. I think about my computer. It's my PC, and it happens to run Linux and it happens to run Windows, and I move smoothly between the two.
Right, and it avoids the need to do a dual boot or have that VM, and it's just you boot your machine up and you can use whatever you want to do. You can play a Windows game, you can switch to do your ML workload that's a Linux app. It's a really cool experience.
What are some new features in WSL and some of the new features that have been added that we've heard about this week?
Sure. The two that I'm most excited about are the GPU paravirtualization work, which Masumi alluded to. It allows you to do compute workloads right on WSL via a virtual GPU adapter that we expose into the lightweight VM. So that one's really exciting. It lets you do ML, AI training, like different workloads like that. The other one that released, gosh, it was like 2, maybe 3 weeks ago, we called WSLg. That's a really awesome open source project that we've been working on with a couple partners inside of Microsoft that allows you to run graphical Linux applications very tightly integrated with Windows. And it's really awesome, has a lot of really cool performance characteristics like shared memory between the Linux app and the Windows app. And it's been getting some really, really good feedback so far.
If you don't mind, I'll dig a little bit deeper into that. It seems like we're building bridges here, not just bridges between operating systems, but bridges between worlds and doing some really interesting computer science to make these things work. You talk about shared memory, but we do know that there's ultimately like a Hyper-V heart or a virtualization platform heart at this thing. Can you help us understand where the lines are drawn as WSL sits inside of Windows?
Yeah, good question. So essentially, a couple times we've mentioned this lightweight VM. And we've tightly integrated this with Windows, so it only runs when you need it, right? So if you launch a Linux graphical application, we will not spin up that VM until you've launched for example, the Linux version of Firefox or something. That is, we're able to do that because the virtual machine boots so quickly that, we're talking on the order of, seconds to get this VM from not running to, running a GUI application. So that's one thing that we like to emphasize, is that these things are there if you need them, and then when you're done using them, we'll, behind the scenes, they'll go away, and you'll get all of the all the resources that were being used by that VM back, and it's kind of integrated in a way that you don't need to be thinking about. Oh, now I need to boot this VM, and I'm done with it now. It needs to go away. We just do all that for you.
Mm-hmm.
So, yeah.
I'm hearing a lot about ease of use. As we turn to the next question to Masumi, I'm seeing a lot of ease of use and a lot of performance. When I use WSL2 on my machine, it just feels like I'm on the metal. I'm curious what your experience has been working with WSL2 in terms of performance and ease of use.
So with respect to ease of use, it's become really easy to install WSL2 now. Previously we had to manually go through steps when we were first doing this, but now an automatic step has been provided. So if you're part of the Windows Insider Preview solution, then you can just install that specific beyond a certain version of that Windows, and then we just run like a WSL2 install command, and with the next reboot, your Linux is installed the first time. It'll take a little time, I've seen, because I think it's completing the installation. You're adding like your username, password, but after that it like boots really fast within one like when I start WSL2 within a second. So ease of use, it's really easy to use. And then for the performance, we have done some performance evaluation, and running like an application in Windows versus WSL2. Like as Ben mentioned, we've been running the AI applications, and it takes almost 99% of the performance is seen in WSL2 as is in Windows. And even with paravirtualization, running TensorFlow, doing some of the training for using WSL2, we saw close to 98% almost performance between what the application was between running it in the host versus the WSL2. So I think it's really getting there where you get both the ease of use as well as the performance.
Wow, so we're really hearing about performance, even though this is a virtualized system. You, Dr. Hazra at Intel, are seeing great performance with WSL2, which actually brings up an interesting question for Ben, which juxtaposes the difference between WSL1 and WSL2. Maybe we can talk a little about the architectural differences and why some of the changes that were made in WSL2 really unlock the power of the machine, of the processor that we're sitting on top of. Ben?
Yeah, sure. So, I was at Build with you, gosh, was it 4 or 5 years ago now, Scott, when we announced WSL? And back then, the architecture of WSL was not a virtual machine. It was, a different architecture that had some trade-offs. It was some technology we call Pico. And essentially what we've done, at a real high level, is we had re-implemented the Linux kernel ABI in a Windows driver by hand, and translated Linux system calls to Windows system calls on a per system call basis.
If you could perhaps expand that 3-letter acronym ADI for us.
Oh, ABI, Application Binary Interface. So that's, yeah, so that is, the way that user mode talks to kernel node specifically is what I'm talking about. And that technology was great. It allowed us to get, fairly simple command line applications up running very well. But as you can imagine, there was a very long tail of more complicated applications that used more of that Linux kernel surface area. And it became apparent to us that this was, a battle that would be forever going. And Linux is not a, it's not a standard, it's not a static target, right? Like they're continuing to add features that new technologies take advantage of. So we started looking at using the same Linux containerization technology we use in Azure to have the same user experience running client Linux applications on Windows, and that's what WSL2 is. And so it's a lightweight VM. I mentioned it before. We only run it when you need it, and we have we built a lot of tight integration pieces on top of that VM. For example, being able to share your Windows file system with the virtual machine. Launch Windows applications from inside the virtual machine. We try to blur the lines between what you think of as a traditional virtual machine, and the end goal was to make the WSL 1 or 2 using them should feel the same. It's just with WSL 2, since we're using the real Linux kernel, and now we recently updated to the 5.10 version of the Linux kernel, we're able to do more things. And it lets users run, like the GPU paravirtualization is a great example of something that's only possible with WSL2.
Mm-hmm. We've got a question here in the chat from Luis, who's asking if the roadmap for WSL is published somewhere, or where can we engage as a community to hear about those next big features coming up?
That's a great question. We have a very active GitHub. It's github.com/Microsoft/WSL. That's the best place to kind of get the pulse of the community. We also have a blog that I believe we use, the command line blog, which the terminal and us, we both share. That's the best place to see announcements of new features and things like that. In terms of roadmap, we should work on having, we have some awesome things in the pipe that, I think might be a little premature to talk about, but I want to get those out there. So we should, let me circle back and we'll get something published, because we're working on some really exciting stuff.
Yeah, I think it might be cool to have something on the GitHub. I mean, you're doing a lot of this work out in the open anyway. Great opportunity to talk about that.
Yeah, and especially I called out WSLg earlier. So WSLg is really the model we're moving towards, where it's fully open source and users can contribute to it. And we want to get there. That's the goal. So.
Fantastic. Here's an interesting question. This one's anonymous that says, and perhaps we'll do this for Dr. Hazra, is there a way to integrate other hardware accelerators into WSL? We're seeing how we can access the GPU, but what if I wanted to run like an Intel FPGA programmable acceleration card, an Intel FPGA pack or something like that?
Yeah.
Is that theoretically possible, or is that a thing of interest?
Yes, that is. And we are looking at something similar that was done for paravirtualization for GPU. For the VPU, you mentioned FPGA, but we are also looking at the VPU and following the similar architecture that was done for GPU in order to make the paravirtualization for VPU available with WSL2 as well.
Mm-hmm. Now, here's an interesting question for Ben from Michael, and I think this is a good question because it might actually challenge our own mental model of how we think about this here. The question, I think, is respectfully to Michael incorrect, but let's ask Ben what he thinks. Are Linux processes able to call Windows DLLs directly? Could a Linux binary call into WSL? And if not, what's an interesting way that they could potentially talk to things? Is it really process isolation? I think I remember seeing us piping Linux processes to Windows processes and back. That would be an interesting question from Michael.
Yeah, it's the latter. Interoperability, is at a binary DLL level like that would be pretty difficult, because the binary format of Linux is different than Windows. Linux uses something called ELF, and Windows uses something called PE. So they're not, at the ground level, they're not compatible binary formats. But you can accomplish a lot of the same goals by launching a Windows application and interacting with it via some kind of IPC mechanism, a pipe or a socket or something like that. And we see people do that a lot. Like one really cool example of that is the Visual Studio Code folks have an awesome extension called the Visual Studio Code Remote. And basically what that does is it lets you run Visual Studio with Linux on the back end. And so basically the only thing that's being done on the Windows side is we're painting the UI, interacting with the virtual machine over IPC, and you're running the actual version of Visual Studio, Linux version of Visual Studio under the covers, and just connecting to it via via the IPC mechanism I described. So you can do some really cool things. I would encourage you to check out VS Code Remote, because that's exactly what you just described.
That's a really great point, and I would encourage people to take a look at the developer keynote that I just came out of myself. We did something that was really, really clever that I think Ben would appreciate. We were actually in Visual Studio 2019, running on Windows. We were then talking to a .NET application, and it could be anything, Node or whatever, talking to a .NET application running in WSL on the server, and then we told Visual Studio 2019 that our browser was a Linux browser back in WSL. So we had Linux server, Windows application, Linux client, and I pressed F5, and I was doing real interactive debugging across operating systems and looking at it all, and then running, in fact, playwright tests inside of the Linux-based browser, which was pretty darn cool. Here's a great question from Connor in the chat here that says that their school is using VirtualBox right now for their IT students, and Connor feels like they cannot use WSL2 and Hyper-V on the laptop at this moment. Answering this for myself, I'm assuming that means you may not be using VirtualBox 6, because VirtualBox 6 has that feature that it uses Hyper-V and would in fact allow you to use Hyper-V, VirtualBox, and WSL all at the same time. What do you think, Ben? You're probably biased like I am, but do you think that Connor should try to get this running on their desktop PC during the next year? WSL is worth it, don't you think?
I mean, I think so. And also, you know, we have built, speaking up from the Hyper-V team, we have a technology called HP Plat, which I don't believe VirtualBox has done this, but I know VMware and the Android emulator have both moved to this, hypervisor platform API set that we have introduced recently. And that would allow you to run WSL and, you know, a different virtualization environment side by side. The issue with running Hyper-V side by side with VirtualBox is there are different types of hypervisors. One's called an L1 hypervisor and one's an L0 hypervisor. Essentially, they don't interact very well. But the introduction of these HP Plat APIs that we've done over the past year has enabled you to do those sorts of things. So, but yeah, I would suggest trying it out. It's easy to turn off, to try it out and switch back if you're not, if it doesn't work for you.
Here's a great question from Masumi from Nagendra in the chat, who's saying, what is a feature that excites you on WSL2? What's your favorite WSL2 feature?
So for WSL2, the thing that we are primarily looking at is doing the compute with the AI like inferencing. And today we are using it for the GPU, but our hope is that we can make all the different accelerators which are available on the client available through the paravirtualization mechanism in WSL2, so that we can get really good performance in the client itself using the accelerators when running these AI workloads.
Yeah, I'd really like to understand how that works, because it really blurs the line between what's virtualized and what's not. I'm curious, Ben, how are we able to access the hardware? Is it all just virtualization trickery, and that those virtualization layers have just become so well tuned that we don't see the perf hit when we're accessing real hardware in a virtualized environment?
I think it's fair to say that. Mechanically how it works is when you start the WSL virtual machine, we expose a virtual GPU or device into the VM that it's called debug, and it's something that that's how all of these things are interacting with the host hardware, right? That's one aspect. There's also some drivers that are injected, so for Intel to allow us to use their compute engine, we need their user mode driver inside the Linux image. We will automatically map that in when we start the WSL VM, and then they talk over this debug kernel interface and get right at the hardware on the host. And that's at a high level how it works. And we're able to achieve really good perf with that, and it's some technology that we've been working on for a while, and we're looking to extend it as well. As Masumi's alluded to, we want that to be really general purpose and available to use all sorts of devices.
Mm-hmm. And I would like to add that our graphics team, they have been working on enabling this. So they have worked on bringing our Gen 9 and Gen 11 graphics drivers to work with WSL2 for the integrated GPU.
That is a really great point, because a lot of us, myself included, on the laptop that I'm on right now has an integrated Intel graphics processor, and I'd love to be able to exploit it as much as possible, whether it be in Windows or in Linux. And I think that's actually a theme, isn't it, Ben, to make WSL just work. We heard about the WSL - install. We're going to talk a little bit later about how WSLg is architected such that it will just work and you can't mess it up. I really want to be able to unlock the power of my hardware, no matter how I choose to use it.
Right. Yeah, that's a great point.
Yeah. Here's a great question from Julian in the chat who's saying, could you understand, maybe explain the specific reasoning between WSL kernel updates? They're in Windows Update, they're not. Sometimes it tells you you have to go and download a thing. Sometimes it doesn't. Explain to us how the kernel, the Linux kernel, gets updated within the context of WSL, and then whether or not there's a way to control that with group policy.
That's a great question. So you're correct. The kernel is not part of the Windows image. It's serviced separately through Microsoft Update, right? So the same way that your machine will get, for example, graphics card updates or updates to other Microsoft products, that's the mechanism that we service the Linux kernel through. If you want to, make sure you're up to date, you can run WSL-update, and that will query and make sure that you're running the most recent kernel. And as far as group policy, I know that there are some group policies that may disable Microsoft Update, but you are still able to manually make sure you're running the most up-to-date version by using the command that I just talked about, WSL-update.
Mm-hmm.
And there's a couple reasons why we have been servicing that kernel. One is obvious, as security fixes come out, we'll release versions of the kernel that have the fixes to those. But also, we will take user feedback, and usually from our GitHub, somebody will say, "Hey, I'm trying to do this. This kernel that is the supported kernel is missing this config flag. Can you please add it?" And then that'll get added to the config, and then they can use whatever they want to use. So so it's also driven kind of by the community on what you tell us what what you want to use WSL for, and we we'll add things to the kernel as necessary.
All right. Here's a fun question from Coursera. Our friend Nuno in the chat is asking, what are the distros that the panel is running as their default? And I'll start. I actually recently switched from Ubuntu 18.04 to 20.04, and that is my default. But I also have a number of other distros installed, and I also use Docker for Windows. Masumi, what distro did you decide on as your default on your daily driver computer?
I've been using the Ubuntu 20.04 as well. We started at 18.04, but have switched to 20.04.
What about you, Ben?
Yeah, I have used. I think I've primarily been using 20.04. But I'll also give a shout out to Alpine. I like to use a non-glibc distro because I've been bit in the past by breaking them, and so I try to use it regularly to make sure that that the goal of WSL is to be agnostic to what distro you're using. And some distros like Alpine use a different C library, and we got to make sure that we keep it running really well for there. So I try to use that as well, just to make sure we're keeping our the entire ecosystem healthy.
I'm curious, Ben, there's a question here about someone who's migrating from Cygwin, and of course Cygwin isn't Linux. It's Linux-y. It's GNU utilities that have been recompiled against Windows, so it's Win32 versions of your favorite things like Bash and awk and sed and things like that. Is there a reason for someone to migrate from Cygwin if they have build scripts and VS build jobs that rely on that Cygwin-like environment?
That's a good question. I think you could, in some ways, you could see WSL as a replacement of Cygwin. But Cygwin's goal is really to provide a Linux-like scripting environment, right? And WSL's goal is a little bit different. That yes, we allow you to run Linux scripts, but the goal there is to emulate Linux and be able to run Linux applications. So I think there is a place for both. And I think the one real big benefit that I would have as an old Cygwin user from back in my college days, I used it all the time. I would have issues, and I had a lot of time debugging it. And I think the benefit that I've had with WSL is that it isn't kind of this tweak of it is actually Linux, right? Like if you're running Ubuntu 20.04, you're running the exact binaries you'd be running on at Ubuntu 20.04 VM or physical machine. So there are some like tweaks that maybe you'll run into less binary compatibility issues and things like that. But I do think there's room for both. It's really if it suits your needs, that's great. But I think there's a place for WSL as well.
One comment, Ben, is
Sure.
Do you believe there will be a performance difference as well? Using Cygwin libraries instead and or WSL2, you might have a better performance with WSL2.
It's definitely possible. So I know that Cygwin uses I think it's called a lot of stuff in my brain, MySys2, which is essentially kind of like a POSIX compatibility library, which is great. You know, I don't want to discount that project. I think it's a great project, and people have been using it for many years, and will continue to do so. But yeah, I do think there are some benefits to using, you know, mainline versions of Linux, and you know, you have Canonical is behind their WSL image that they put in the store. Microsoft is behind the platform, and really from a support perspective, that's one of the big wins for me.
Yeah, I'll offer, actually, if you don't mind, I'll offer my own thought on that, because I believe that if you are using Cygwin to simulate Linux, then you're not using it appropriately, and you should consider using WSL2, because WSL2 is Linux. But if you're using Cygwin to put together scripts and build scripts that are in the Bash language that you like to automate your Windows jobs, then that's a great and awesome thing for you to do with Cygwin. But if you're using Cygwin to jump in and out of Linux world, and you're hopping back and forth over the edge there, then that's probably an example where it's not useful. One of the things that I've done to basically have the best of all worlds, and this is me personally, is PowerShell runs on both Linux and Windows. So I've personally written build, test, deploy scripts that are .ps1s. I use a shebang in my PS1 script, which Windows ignores. And now I have build, test, and deploy scripts that run automatically on Windows or Linux. And that is a really great way for me to get the flexibility that I want without having to necessarily pick favorites. All right, great question here, and a lot of questions in the same theme of this question from Derek Arnold in the chat, who has been experiencing issues with WSL2 and the work VPN. There's a lot of questions about networking, about NATing, confusion around NATing, IP tables, Windows firewall. Could you, in the last few minutes here, Ben, give us an understanding of networking and how we can do the things we want to do with WSL2?
Yeah, sure. I will, you know, when we talked about WSL1 earlier, WSL1 had different characteristics with network. You were just another process, and so therefore you're on the same network stack as Windows applications. And then WSL2 is a VM, so there are some challenges there that we're aware of and working towards. So we, you know, without committing to anything, I will say that, you know, networking is an area that there's room for improvement, and we're working to come up with a much better networking story. I think there's a lot of threads on our GitHub where people have worked around some of these issues. That encourage you to, you know, kind of, if you're running into an issue, search our GitHub, and we have a lot of smart users there that have likely found workarounds for you. But you know that you know, the things that I lose sleep over are the user pain points, and that's one of them. So that's something we're actively working on.
Mm-hmm. And Dr. Hadra, Dr. Matsumi, are you finding that Intel is getting more and more excited about WSL2? Are you finding yourself talking about WSL2 inside Intel and kind of converting your colleagues and saying, hey, did you know that Windows can do this on your PC that you already have?
We are starting to use WSL2 in different usages, as I mentioned, especially for the AI compute. And from our perspective, our graphics solutions, today it's working for the Gen 9 to 11, but we are also moving it for our Gen 12 Iris Xe graphics solutions. So there is more interest in getting WSL2, with different accelerators, the VPU, as I mentioned, we are doing that. And there are other projects as well, like for telemetry, we're looking at what we can do if we wanted to use it within WSL2. So there is interest, coming up as we move forward.
Mm-hmm. Ben, do we have a sense of when WSLg are going to be kind of like released? Because we know that right now there's a lot of insiders builds and a lot of people want to get on the edge, but there are many folks waiting on long-term support versions. They want to be able to take their existing machines, their machines with their Intel graphics processors, and they want to start running Linux applications immediately side by side with their Windows apps. Do we have a sense of time frame?
Yeah, to echo what Satya said in his keynote, the next big version of Windows has this stuff in it. It's a great update, and this is part of it.
So that is our answer. And do we know when GPU parallelization will release to retail?
The same time.
The same time.
Yeah, we're working on a beta version right now. So.
Really, they're working. So is that now, Masumi? Is that something that we can go and look at the Intel websites and go and download those drivers and run them on Insider's versions of Windows?
You have to. For GPU paravirtualization, at least that's how I've done it. Maybe Ben has a different answer, but I had to install the beta version of the graphics driver for the integrated GPU to get paravirtualization working.
Yeah, that's my understanding, is that the GPU compute drivers are in the beta, now. But as we move towards, the stable version of Windows, I expect those to also make it to stable versions of the Intel drivers as well.
Correct.
Fantastic. Well, we have had a whole bunch of great questions. I'm sorry that we don't have more time to hit more questions, but I'm on Twitter. Ben is on Twitter. Dr. Hazra, are you in fact on Twitter as well?
No, not really.
All right. Well, we will release you from being have to answer all the great questions, but our friends in the chat, if we didn't answer your question, certainly you can hit me or Ben up and we'll try to find you an answer. Be sure to check out the My Build Intel featured partners page, as well as intel.com/Microsoft Azure. And you can find Intel Business on Twitter, although they probably won't answer your technical questions on WSL2, but you can check them out on Twitter, on LinkedIn, on YouTube, and on Facebook. And I want to thank our experts for hanging out with us today at this Ask the Experts session. Dr. Mustumi Hazra, Principal Engineer at Intel, Ben Hillis, Senior Software Engineer Lead at Microsoft, and myself, Scott Hanselman. I hope you all have a great build, and thank you so much for spending time with us today.
Thank you.
Yeah, thank you for having us.